we're going to start by introducing what's called the imaginary numbers. And the nice thing about this here is it's called I. So equations such as x squared plus 1 equals 0 have no real solution. So mathematicians define the imaginary numbers to represent their solutions. The imaginary unit, I, is defined as I equals the square root of -1. This is useful when working with square roots of negative numbers. So this is our definition. We're going to call it that, and so whenever you use the letter I, you mean the square root of -1. A pure imaginary number is written in the form b times I, where b is the real number and I is the imaginary part. So let's say you had like 5i. Okay, we know where 5 is on the number line. 5 is real. That is a real number. And I is an imaginary number. You're basically going to, well, you're sort of going to treat it like an x. Okay? You can't add 5i to another 5, but you can add 5i to another 5i. So the i's can go together, but not with regular. So here's how you do it. You're going to rewrite any negative square root as -1 times that number. Then we're going to simplify that number if it's not a perfect square, and then you're going to simplify the radical with that fact. So here's how it works. Number 1, I have the square root of -9. You'll notice that all of these are negative numbers. So I'm going to rewrite this as the square root of -1 times 9. -1 times 9. And now I'm going to break it apart because I can. So it's the root of -1 times the root of 9. Sure, yes, if that'll help turn off the light. Just the middle two. Thanks. Okay, so this is what I'm now calling I. Okay, so I'm going to replace that with an I. And then what is the root of 9? 3. Vince, question?
Well, would you have to do it that way, or can you do the square root of -1 times 3 squared, and then put that by I next to it?
As long as you end up with 3i at the end, if what I am understanding your question to be, that's okay.
But then, like, I don't know, like, it just confuses me.
Well, I've only done one example. Let's do a few more. That's what I was saying is, it's not confusing, but it is brand new. So let me do a few more examples before questions, and you'll see how it works out. Now you may notice that I switched them instead of I3, because we always put the real part in front. That means there's 3 times I. Always put the real part in front. Now I have -196. So I'm going to do the same thing. I'm going to separate it. -1 times 196. Well, those can be broken apart. And this is I. So I'm going to put an I there. Now, if you don't know your square roots up to a bajillion numbers or up to 25, 196 is actually 14 squared. So this turns into a 14. Okay, and again, I'm going to put the 14 in the front, but that's all there is to it. So if you have a perfect square, it just turns into that number. What happens if you don't have a perfect square?
About that, I guess, like, if you have a perfect square, then why do you have to do all those extra steps? You can just take the square of 196 and just put it.
Because I'm explaining the steps right now, these are the notes, and it's the first time we've gone over it. So I'm assuming that eventually you will get there. But right now, since I'm showing all the steps and teaching, I'm showing all the steps and teaching. Does that make sense? You're just 3 steps ahead. All right, so say I'll have square root of -5. Okay? negative 1 times root 5. So you could actually go straight to that, right? And then this turns into I. That's your I. And this is square root of 5. And you know what? There's nothing I can do with that. So I'm done. I mean, you're basically done. Now here's the thing about this. This root 5, when we have a radical, you always put the I in front of the radical. So again, this is how we write it. Because sometimes, people will like extend the radical really far, and then it looks like the I is under the radical. So to make sure you never make that distinction, the I always goes in front of a radical. It's just convention to make sure you got the number right. Okay? Any questions? All right. So we're going to do a couple more. I now have the root of negative 80. So I'm going to separate it. Okay? The negative root of 1 is I. Now the root of 80, I'm going to break apart, right? Because there's all these different ways, but this is a skill you already have. You already know how to simplify radicals. So I can do 2 times 40. I could do 4 times 20. I could do 5 times 16. Or I could do 8 times 10. Do you remember which pair you're going to pick and why? Why 5 times 16, Keith? Exactly, because 16 is a square root. And it's the biggest, too. Like 4 times 20 would work, because 4 is a square, but 16 is bigger. So you always want to pick the biggest one. And then this turns into what? 4. So your answer is 4i times the root of 5. So the real number goes in front, the root goes in the back, the I is in the middle. All good? Yes, Shelby. Not during notes, really. That would be the best time to hang on to it. Okay, so number 5, negative 1 times 32. I'm hoping that you're starting to see where this is going to go. Can you see where this is going to go? All right, so we're breaking these apart. How are you going to simplify root 32? Because that's just an I. So you have to simplify root 32. You may look here for some inspiration. What's the biggest square root you can take? Yeah, 16. Good. So this is going to be root 2 times 16. And we can now simplify it as, what is root 16? 4. So this is 4 times I times root 2. Good? Okay, so I'm just going to ask, if I asked you to do number 6 on your own, how many of you think you could? I'm not asking you to do it, I just wanted, if you think you could after these 5 examples. That's a little more than half. Okay, thank you. That's just checking in to see. Let's do this one last example before we move on. So I'm going to break it apart. Negative 1 times 192. 192 is a pretty big number, right? So I can divide it by 2. By 2 times 98. That's still too big. How about 3? Does 3 go into it? Well, remember the 1 plus 9 plus 2 trick? So if you add the digits, that gives you 12. So 3 will go into that. And it goes in 64 times. And that's a big number that I like. So I'm going to just go with that. So this turns into What does it turn into now? I, yes. This is a root 3. That just hangs out. You can't do anything with that. And then what's this root 64? Everybody knows it's 8. So your final answer is 8i times the root of 3. Good job. All right, so that's simplifying. That's how you work with I. When you get answers, when you do the quadratic formula, you solve something, instead of no solution, now you can say, oh, I get it. Or I can get an answer now. So can you see how to solve this problem? The whole point is solving, right? So I is just one of those. So how do we solve it? Yes, let's see. Okay, everybody, let's subtract 81. And then? Both sides. Perfect. Because you don't want x squared, you want x. All right, so now I have x equals the square root of negative 81. We now know how to deal with negative square roots. So it's going to be negative 1 times the root of 81. Right? Everybody with me on that? Where do we go from here? X equals, what's that? That's I. What's that? Okay, so this is 9i, right? Okay, is there any problem with that? So I'm going to remind you all of the fundamental theorem of algebra. The fundamental theorem of algebra says, and I'm grossly paraphrasing here, but the fundamental theorem of algebra says, if you have as many solutions, or you have up to as many solutions as there are powers. So this is an x squared. I should have 2 solutions. When you have a parabola, how many solutions should you have? You should have 2, but we only have 1 solution. So what's the problem here? What are we forgetting? There's something we're forgetting. It's in the Adams family quadratic formula song. Remember? Plus or minus, plus or minus. Remember that? Everybody remember plus or minus, plus or minus? Because the square root of 81 is both plus 9 and minus 9. So now I have 2 solutions, and now I am happy. Solutions make me happy. Yes, questions? So I thought I saw a hand. You good? All right, so let's move on. Number 8. Use your algebra. Get x alone. What are we going to do first, Shelby?
Minus 9.
Good. So I have 2x squared equals?
Negative 8.
Negative 8. Zombie, what are you going to do next?
Divide 2.
Yep, that's exactly what I would do too. So x squared equals negative 4. Next step, Isabel, what are you going to do? Square root. And Vince, can you go straight from here to the answer?
X equals 4i.
No. Try again.
Wait, what?
It's okay. What is the square root of, huh? 2i is one of the answers. That is half correct. Yes, there we go. Now you are fully correct. Positive, negative. Good job. Okay. Feeling pretty good about this stuff? Not bad, right? Okay, number 10. I'm just going to go straight down. What do you do to get the x squared alone? Everybody say, we are going to... All right, perfect. Okay, x squared equals negative 12. Let's square root both sides, shall we? Okay, so the root of negative 12 is going to be negative 1 times root 3 times root 4. Yeah? All right, so simplify everything. This is I. This we just leave alone. It can't be anything else. But then the root of 4 is, it's not 2, it's plus or minus, plus or minus, plus or minus. Okay. Okay, and then finally to write it properly, the way you'll see it, okay, what comes first? Yes, plus or minus 2, and then the I, and then the root 3. There you go. Very good. Okay, I'm going to give you all 30 seconds to do number 9, and then I am going to put the answer on the board in 30 seconds. Go. It's actually a little more than that, okay? Did you get plus or minus I times the root of 6? Yes? Very good. Very good. Okay, so you see how we are doing these? Any questions right now? We're going to turn the page. So the whole point is solving, right? To find our zeros. Now, turn the page. We're going to look at some interesting patterns that I does. By the way, I'd like you to do, since you're turning, your homework assignment is going to be 1 through 10 on the following page where it says homework. So you're doing 1 through 10 on your own. We're almost to the point where you can do it on your own. Okay? We're not going to do this right now in the interest of time, but we'll probably do those tomorrow. So here's the fun things I want you to, we should be able to finish this. I has some unique properties. Okay. Products of I. So, we know for sure that I is the square root of -1. And so that equals I. Nothing to do there, just the definition. But here's the fun part. If you square it, when you square a square root, what happens?
It cancels out.
It cancels out. And you're left with what's inside, which is -1, which is a real number. It's like a real boy. Pinocchio reference. So I times I is -1. And then here's the fun part. If you do that again, let's say you do I cubed, then I squared times I. We know I squared is a -1. So that's -I. If you square it again, you get I squared times I squared, which is -1 times -1, which is +1. So it's going from an imaginary to a real number, back to an imaginary to a real number, and guess what happens if you multiply it again? It goes back to imaginary. So I to the 5th is like I to the 4th times I, and I know that I to the 4th is 1. So I to the 5th is I. I to the 6th is like I to the 4th times I squared. I to the 4th is 1. I squared is -1. So that equals -1. I to the 7th is I to the 4th times I cubed. I to the 4th is 1. I cubed is -I. So guess what? It's -I. And I to the 8th is like I to the 4th but squared. Okay, so that's -1 squared, so that's 1. It's a little crazy, but look, do you see the pattern? If I zoomed in a little more? Or if I asked you this, so this is I to the 5, 6, 7, 8, what's I to the 9? It's I. What's I to the 10? It's what's I to the 11? And I to the 12? Okay, so what's I to the 15? This is 12.
Negative I.
So I to the 13, I to the 14, I to the 15. Right. It just keeps repeating itself over and over.
So every 4 numbers.
Every 4
you
numbers.
eventually get I. Every 4 numbers.
Yes.
But then if you have more than 4.
Then you have to go down the
So,
thing.
the ones that are that you can divide by 2 or 4 is -5, and -1. Or no?
Divide by pure numbers? No. No, it's just this pattern. It's just the pattern because of the definition.
So then 14 is -1.
How do you come up with that, Shelby?
I just counted them in a row.
You counted to 62?
Yeah, it's not that hard.
It is not that hard.
Right?
Absolutely, you are right.
Think,
Is there an easier way than counting?
probably, but
Dividing by 4?
Okay, so Josh says divided by 4. Why?
Because every 4 numbers is a positive. And if you have anything.
So if you divide 62 by 4,
you get 8.
no, 62 divided by 4 is 15 with a remainder of 2.
So then you go
So,
to
right.
I.
Every 4 it's going to repeat, right? Okay? So if you got a 15, then you're up here, and where would it put you if you have a remainder of 2?
The second one, negative I.
That's it, yeah, you are correct. Right. So if you just use the pattern, you can do big numbers. Which is, you could do it either way. There's nothing wrong with counting. Okay, but 62 divided by 4, that gives you 15 with a remainder of 2. So every time it goes in, it goes back to the pattern, and then the remainder of 2 gives you an answer of -1, which is all very good. So you should be able to, it's just this fun little pattern, like I said, that works with I.